Hello everyone, welcome back to Tough Math, a YouTube channel where tough math problems are solved and discussed. Most of these problems come from various national and international mathematics competition given in the past several years. And they appear here either in their original forms or in their reformulated versions. So here are our problems. The first one. The circumference of the front and rear wheels of a toy car are 6 and 3/14 centimeters and 8 and 1/18 centimeters respectively. At any given moment, the points of contact of the wheels with the ground are marked with red paint. Find the distance the toy car has to travel so that the red marks are again on the ground at the same time. Okay, so first we convert the given circumferences, which are mixed fractions, into improper fractions. So 6 and 3/14 is equal to 87 over 14. 8 and 1/18 is equal to 145 over 18. And since 14 equals 2 times 7 and 18 is equal to 2 times 3 squared, then we use the factors of 14 and 18 to convert this mixed fraction or improper fractions into integers. So you have 87 over 14 and 145 over 18. Okay, so convert to integers for convenience. This is for convenience, for computational convenience. And how do we convert this to integers? Well, of course, we get rid of the denominators, 14 and 18. So we multiply 87 over 14 by 2, 7, and 9, and 145 over 18 by the same product of factors, 7 times 9. And this gives us 783, 1015. Okay. Now what do we do with this ordered pair? Okay, so the problem as it is looks a little bit difficult to analyze. So we consider a similar but simpler case. Instead of the given values as circumferences, let's consider the rear wheel to have only 3 centimeters circumference. So consider the rear wheel to have 3 centimeter circumference, and the front wheel, no, 3 is the front wheel, because usually it's the smaller wheel that is in front, and then 5 centimeters for the rear wheel. Okay, so it's like this. Suppose this is the 3 centimeter circumference wheel, and this one is the 3 centimeter circumference, while this one is the 5, and we mark this point that is in contact with the ground by A, and we denote this point on the circumference of the wheel, which is in contact with the ground, by the point B. Okay, and then we let the car run a certain distance, like this. Oops. Okay, so okay, my drawing is not accurate. It's the smaller wheel that is in front. Okay, let me erase that. So this is the 5 centimeter circumference wheel, and this is the point mark A, and this is the point mark B on the smaller wheel. So this is 5, this is 3 centimeters, and they are connected here. And then we allow the toy car to move, so that the rear wheel is now here, and then the front wheel is here. So now this is our point A prime. Actually, it's the same point, but let's just put a distinguishing mark and make it A prime, because it has now moved. Yeah, the car has already moved, and this is B prime, which is actually just B. Now the question is, what is the distance between A and A prime? Well, the distance between A and A prime is, this distance is 15 centimeters. And similarly, the distance between B, this one, and B prime is also 15 centimeters. And what do you notice of the number 15? 15 is actually the least common multiple of 3 and 5. Okay? So, what do we do with the problem at hand? Let us take the least common multiple of 783 and 1015. So, that is what we do. LCM, I would like to change color. Maybe this one. Okay, so the LCM of, so the desired distance, when the mark points are on the ground again at the same time, the A prime, and then B and B prime, and we will now have LCM of 783 and 10, 15 or 1015. This is LCM. 783 is equal to 27 times 29. And 1015 is 35 times 29. Since 29 is common, we can put it outside. So we have 29 LCM of 27 and 35. Now, since 27 and 35 are relatively prime to each other, just like 3 and 5 in our simpler case, so we simply multiply them. And multiplying them gives us 29. If you multiply 27 and 35, we get 945. And so we have this number, 27409. Now, so since to get this result, we have multiplied the original fractions by a certain number to make the fractions become integers. Now we restore it. We instead of multiplying, now we divide, so that we restore the original given values. So to restore, so I will write here restore. It's 27409. This time we divide by the number which we used in multiplying to convert the improper fraction into integer. So we multiply it by 2 times 7 times 9. This time we divide it by 2 times 7 times 9, and the result is 217.5 centimeters. This is the distance excuse me. This is the desired distance traveled. When the toy car has traveled 217.5 centimeters, the A and the A prime are on the ground. At the same time, the B and the B prime are also on the ground. So that's the answer, 217.5. Okay, now let's look at the second problem. A motorcyclist covered 2/3 of a total journey at his usual speed. He covered the remaining distance at 3/4 of his usual speed. As a result, he arrived 30 minutes later than his usual arrival time. If the total journey was 270 kilometers, what is his usual speed? Okay. So here, first we let S sub u be the usual speed of the motorcyclist. Also, we have T1. By the way, this speed is in kilometers per hour. Per hour. Time spent covering 2/3 of the distance. And then T sub 2 be the time spent covering, of course, since 2/3 has already been covered, then the remaining is just 1/3. 1/3 of the distance. Which is 270, by the way. Okay. And T, the usual travel time of the motorcyclist. Okay, so from this we have, of course, the first equation is the usual speed times the usual travel time equals 270. And then the usual speed times the T1, the time spent covering 2/3, is equal to 2/3 of 270, which is 180. And then SUT sub 2 is 1/3 of 270. Wait a minute. Three-fourths of the usual speed times T sub 2 is equal to 1/3 of 270, which is 90. Therefore, SUT sub 2 is equal to 360 divided by 3 equals 120. By the way, this is kilometers, because this is distance. This also kilometers. Okay, this one is kilometers. Okay, now usual speed times T1 plus T2 is equal to SUT1 is 180, okay, and then SUT2 is 120, so that's 120. Which is 300. On the other hand, SUT1 is 270. SUT, not T1, is 270. So from which we obtain, get S sub U, the usual speed, is equal to 300 over T sub 1 plus T sub 2, and this is the same as 270 over T. Yes, T. However, T1 plus T2 is 30 minutes longer than T, so we have, this is 300 over T plus 1/2. Okay, maybe I can add it here, somewhere here, just for emphasis. So also T1 plus T2 is equal to T plus 1/2 hour or 30 minutes. Okay. So cross multiplying we have 300t is equal to 270t plus 135. Therefore, we have 30t equals 135, or t is equal to 135 over 30 equals 4.5 hours. Therefore, hence, SU is equal to 270 over 4.5, and this gives us 60 kilometers per hour. So this is the usual speed of the motorcyclist. Usual speed of the motorcyclist. Okay, so that's it for this video. However, I will leave you this challenge. Okay, the integer n is 24 digit number formed by concatenating the natural numbers one, two, three, four, and so on, 9, 10, 11, and so on. We have 100, 101, 102 without any symbol or punctuation mark separating them. What is the remainder when n is divided by 9? Okay, so without any symbol or punctuation mark separating them, meaning these commas that I have placed here, 1 comma, 2 comma, remove the commas. That is what is meant by concatenating these numbers. And there should be 2024 digits in this number. So I don't know where it ends. What is the remainder when n is divided by 9? So that's it for our challenge. I hope that before, by the way, the solution to this problem will be, oops, sorry, will be given in the next video. So before you go to the next video, try to challenge yourself, solve this problem first if you can, and then go to the next video. So that is it. That's it for today. Goodbye, and hope to see you in our next video. God bless you.